Good evening, girls. Day before yesterday, I have introduced about digital communication, and in the next class, I think I have told you about error correction and detection and different types of codes. Now, unfortunately, I learned that I have skipped three topics from Unit 2 in data communication, in digital communication, that is amplitude shift keying, frequency shift keying, and phase shift keying, and I didn't give you clear notes for both FSK and TSK. So in these three video classes, I will cover ASK, FSK and PSK. Then we will enter into error correction and detection codes. Now coming to amplitude shift keying. Amplitude shift keying is also called as ASK, and it is a type of amplitude modulation which represents the binary data in the form of variations in amplitude of a signal. That means it will take up a binary data containing bits in the form of variations in amplitude of a signal. I can tell you simply, binary data contains only 2 bits, either 1 or 0. Now if you are carrying binary data 0, the amplitude will be nil. If you are carrying binary data 1, amplitude will be high. This is the process of ASK. Now, any modulated signal has a frequency which has, any modulated signal has a high frequency carrier, and the binary signal when ASK modulated gives a 0 value for low input while it gives carrier output for high input. The meaning is, in case of ASK, when binary signal is modulated, when binary signal is amplitude shift key modulated, it gives a 0 value for low input, that means 0. It gives a carrier output and a high value for high input. If the binary value is 0, it will give low input. If the binary value is 1, it gives the amplitude of that respective carrier input. Now, modulator of ASK. ASK modulator block diagram comprises of carrier signal generator, binary sequence from the message signal, and a band limit filter. In AM/FM also we have learned that we will have three kinds of waves. One is audio signal, the second one is high frequency carrier, and the third one is modulated signal. In the same way, for ASK modulator also, the block diagram comprises of carrier signal generator, binary sequence from the message signal, that means from the input signal, and a band limited filter, band stop filter. Okay. The carrier generator sends a continuous high frequency carrier. The binary sequence from the message signal makes the unipolar input to be either high or low, and the high signal closes the switch, allowing a carrier wave. Hence, the output will be the carrier signal at high input. This point he has already repeated here: 0 value for low input, carrier for high input. Now, whenever there is low input, the switch opens, allowing no voltage to appear. Hence, the output will be low. If there is a high input, what happens? The output will the switch will be closed, allowing some voltage to appear, and the output will be high. The band limiting filter shapes the pulse depending upon the amplitude and phase characteristics of filter, or the pulse shape wave filter, the pulse shaping filter. Now here you can see, first signal represents binary signal. If you observe, the down line, this line is 0 volts and this line is 1 volt. Now, ASK modulated wave shifts between plus 1 volt minus 1 volt, where the 0 volts is the average line or the minimum value. Okay. So, if you observe, whenever the input is high like this, there is some amplitude generated in the ASK modulator. If the binary signal is 0, simply ASK is also 0. If the binary signal is again high, the output is high. In this way, wherever you see the binary signal high at that particular time, for that particular time period, the output of ASK is high. Okay. Now, demodulator. We already learned many times, and I also explained many times that wherever there is a modulation process, there should exist a demodulator. So ASK demodulators are of two types it seems. One is synchronous, one is asynchronous. The clock frequency at the transmitter when matches with the clock frequency at the receiver, it is known as synchronous method. Only till here, if you remember, it is okay. Otherwise it is known as asynchronous method. What is the difference between asynchronous and synchronous? In synchronous method, the clock frequency of the transmitter matches with the clock frequency of the receiver. Okay, simply we can also say it as impedance matching in simple language. Okay, if the clock frequencies are not matched, then it is called as asynchronous method. Now ASK generation will have three blocks like this: sinusoidal carrier, unipolar binary sequence. This is the switch. Here in this case it is open. That means binary our input is 0. If it is closed, binary input will be 1. According to the unipolar binary sequence, ASK output will be generated. Asynchronous demodulator. An asynchronous ASK detector consists of half-wave rectifier, a low-pass filter, and a comparator. Following is the block diagram for the same. I will show you the block diagram. The modulated ASK signal is given to half-wave rectifier, which rectifies only half of the wave, either positive halves or negative halves, which delivers a positive half output. The low pass filter suppresses the high frequencies and gives a envelope detected output from which comparator delivers a digital output. What happens here? What are the different blocks? Half wave rectifier, low pass filter, and a comparator. Rectifier will rectify positive halves, filter will suppress high frequencies and allows only low frequencies, and the comparator gives the envelope of output, and finally it delivers a digital output. You also remember operational amplifier using as a comparator. It compares two different voltages, V reference and V in, and according to the input, the output will shift to either positive saturation or negative saturation. In this case, it is either 0 or 1. Now, asynchronous ASK detector block diagram is this. You can see rectifier block, low pass filter, and a comparator. So this is the modulated signal. From this, the rectifier is rectifying only positive halves. You can see here. Low pass filter is only allowing some kind of frequencies, not the other. And depending upon this signal, the comparator will compare and produces the output, which is a data signal. No. Synchronous ASK demodulator. Similarly, other than in synchronous demodulator, blocks are same. The exception is square law modulator. Square law modulator. It contains square law modulator or detector, low pass filter, and a comparator and a voltage limiter. Additional block is a voltage limiter in case of synchronous ASK demodulator. The ASK modulated input is always given to square law detector. The square law detector is one whose output voltage is proportional to square of the amplitude modulated input voltage. And the low pass filter minimizes the higher frequencies. Comparator and the limiter will help to get a clean digital output. Only these paragraphs are enough. Now you can see this is the block diagram of synchronous ASK detector, which contains square law detector, low pass filter, comparator, and an additional block called voltage. This is all about ASK. Simply you remember whatever points I have explained you in this PPT, and particularly the figures which I have covered in this PPT. If you want, you can study the notes which I have given. If not, you can follow the PPT for all the three cases: ASK, PSK, and FSK. Thank you guys.